Mentally Math! Let's get mental! Alright, gonna give you a couple minutes to get out ahead of me. We know how this works. If you're watching the video, we're doing this from home today. No big deal. Other than that, this is the first class I'm teaching, so I'm way more likely to make mistakes.
Well, we're here to correct your mistakes.
Yes, oh yes you are, and I know you will.
Did you realize Orange is here?
Is he
He's
here?
here.
Oh, great!
Yeah, he is.
Well, you see, this gives us an opportunity for everyone to be here, since we're doing this remotely.
I have a question.
Great to see you, Aunt! What?
When are we going back to school?
Tomorrow, as long as your test oh wait, sorry. Wednesday, as long as your result is negative. But we're taking a video. We're talking about math. So maybe ask me about things that are not math when I finish recording here. Also, my stylus is back at the classroom, so I am just using the tip of a stylus in my fingertips, so
That's funny.
my stylusness might be a little bit off today. Okay, well, I think that probably gave you time to get out ahead of me. If you get to G first, maybe take a look at that. Actually, I'm just gonna say straight up for G first, so that people don't get there first and be asking the same question I'm asking. Unless somebody can think of a way that this is actually mental math of 8 times 3 1400ths 16 times 3 1400ths is mental math. I'm going to actually say that this is an about question, an estimation question, and you can just round 3.14 down to 3 for your calculations.
Can't you just do the exact?
Sure. Can you do that in your head? Do you have some simple way of doing that in your head?
16.5 millimeters. Right?
No, because it'd be 16 times 3.14.
I mean, can't you do 16 times pi?
Oh, well, I hadn't thought about.
5 millimeters.
You know, I hadn't thought about that. They don't say how you're supposed to do it, did they? So okay, we'll do G is leave pi is pi. There we go. You see, that's what I was asking now. Okay. So do G is leave pi is pi. Great solution. Then we don't have to come up with any workaround. Okay, so let's see. I'm going to get started. So I'm going to think 6 and 65 hundredths, 7 and 65 hundredths. No, wait, that was 5, 6. 6 and 85 hundredths. We're getting tricky on us with 3 items. This is just divided by 1,000. So 1, 2, 3. Leave it like that. 12 10,000ths. Then I can subtract 2 to get, or subtract 3 to get 72 divided by 9. By equals 8. Converting decimeters to meters. We don't use the decis much outside of math class. So remember, those are 1/10. 1/10. So that would be 2. Oh, then that would be what? Then 10 of those would be 20. So actually, oh, that would be 2 meters. Interesting. Sort of an interesting one. This could be 12 plus 8 is 20. 1/4 of 24 is 6. Then, yeah, we can just say 16 times pi millimeters. Easy peasy lemon squeezy. No calculations necessary. If we just leave pi as pi.
Easy as pie.
It's easy as pie. It's not a very big pie though. That's a very, very small pie. Okay, then estimate. We haven't had estimation one in a long time. Seems like they kind of put bells on this one, make it easy to note that it is in fact an estimation. So yeah, that's just 3 times 25 is 75. Boom. No worries. Okay, and then today is ratio problems involving totals. And what that means is we are taking our concept of ratio boxes to the next level of figuring out how these can be useful for solving real-world problems. I kind of like these, and so let's take a look at one situation. These are kind of like riddles, or as some people say, kind of like your mathematical escape room of figuring out what information you have, what information you don't have, and using one to solve for the other. So a ratio of football players to soccer players in the room was 5 to 7. If the football and soccer players in the room totaled 48, how many were football players? So, okay, looking at that, first thing we should say is let's organize our information. Will you do that? It might be a bit big. And then I made that even wider. There we go. Okay, so setting up our ratio box. So we've got our ratio and our actual count. I'm just going to do AC for actual count for lack of space. And then the information that we have in the problem, we've got football players. We've got soccer players. We've got total players. Okay, and then, well, okay, so see if you can first set up your ratio box and figure out what information you have and plug it in and what we're missing. So I'm going to give you a second to get out ahead of me and solve as much of this as you can without me. Give like 2 deep breaths here. My morning yoga. Not really. Okay. So first of all, they let us know that our ratio of football players to soccer players was 5 football players to every soccer player. And so we can already start out going, oh, I know what my missing information is there. I just need to add these up for my total. So that's 12. And then it says if the football and soccer players in the room, so the totaled 48, then how many were football players? So what we don't have here are the actual count of football players We'll say that's F. And soccer players. We'll say that's S. Now, one thing about these, an important thing about these is also to discern what is your useless information as far as solving the question you've been given. So, let's see where I guess I'll be able to see your hand. So, if you want to raise your digital hand, who wants to tell me what line of this could I cross out and just ignore on the ratio box? What's our useless information here? Ooh, Ahana! You're up fast.
You could cross out the soccer players because we're not trying to find out how many there are.
You are absolutely 1000% correct. Yes. So we do not need that. And then, so now
How do you give out pom-poms?
Oh, I last year I had digital pom-poms. I'd be happy to say I owe you a pom-pom if you want to tell me on Wednesday when you come back. Okay, so our next thing is to figure out how to use the information we have in order to make an equation that we can solve and end up with an answer that we can use. So taking the rows that we've still got, so we can take that, we can take that, and plug those into an equation. So we've got our 5 to 12, and that's going to equal the ratio of football players to the total. So essentially this is going to, these are going to have to be two equal ratios. Or, you can think of them as equivalent fractions. So we can use our cross-multiplicative goodness to try to figure that out. So setting that up, we can end up with an equation of, let's see, did I go back there? Okay. We can say 12 times F is going to be equal to 5 times 48. And then I'll give you a second if you want to figure out the next step of simplification before me. It would be 12 times F equals 240. Then, oh boy, these are pretty easy to check, because, well, if 2 times, this is kind of mental math, right? Because if, since we divide both parts by that, well, we know that 24 is a multiple of 12, so, and just slap a 0 onto that, so we can say F equals 20 football players. All right, ta-da! All right, Don. People want to give me a 1, 2, or 3 in chat on how you're feeling about this. I mean, it's really a sequence of rules. Okay, these are looking pretty good. It's really kind of a sequence of rules to get you to the answer, and it's a matter of, kind of practicing it enough to where you just kind of remember how to do it. Yeah, Serena?
I think there's a shorter way.
Well, there's definitely a shorter way. You could easily do the equivalent ratio in your head. I understand that, but we are learning a method here that we will apply to future problems. So yes, there's a shorter way. There might be an easier way, but today we're doing the Saxon method of doing it. we've had this talk before, right? Okay, so let's move on. Now, one thing that's kind of irritating is this. I mean, this does seem like something that requires a little bit more practice and follow-up, but you notice what our example number is up here? Example nothing, because there's no other examples. So I thought with this one, it might be a good idea to do some or all of the practice set. So I'm just going to keep going with the practice set here. We're going to use those as more examples. One example? I mean, come on. I mean, yes, I like this quick and simple math lesson, but it really seems like this should require a bit more practice. So we'll do 2 or 3 more. We'll see how we're feeling after the second one. Okay, so the bicycle store. And I'll see if you can figure this one out much faster than me. A bicycle store has mountain bikes and racing bikes at the showroom floor at a ratio of 3 to 5. If there are a total of 72 bicycles on the showroom floor, how can you find the number of racing bikes? Use the Saxon method to find this answer. So let's go through the whole thing. Make your ratio box. Create an equation. Do cross multiplicative goodness. And solve. That's your mission right now. And I will do it very slowly so that you're just kind of checking yourself with me and not just having it spoon-fed to you. Okay, going to make my ratio box now. And I'm just going to go to R for ratio, AC for actual count. Actually, yeah, using my fingertips for the drawing is not so bad. Maybe it feels a little more accurate in some ways. And we've got mountain bikes. And racing bikes at a ratio of 3 to 5. Oh, and sorry, total bikes. We know there are a total of 72 bicycles. It's really the same problem as last time, right? Oh, except we will be eliminating a different line. Spoilers. Okay, and so our total is 8. And why don't I just say M for mountain bike, R for racing bike. And this time, our useless information is going to be the mountain bikes. Yeah, that's kind of cool. Gonna put these up here though. Give myself some space to work with. Ooh, hey, that one did arrows form. Oh, never mind. Okay, so this time our equivalent ratios. Remember, they're just like equivalent fractions, working it out mathematically, is 5/8 to R over 72. Which ends up being 8 times R is equal to 5 times 72, which will get me to 360. And Oh. Okay. So that's not going to work out quite so evenly. We divide each one by 8.
Like that.
That's actually going to be like, if we were doing just 8 into 36, that would be 4.5. Right, but so that would be 45. Racing. Okay, it won't let me do that. So racing. I'll put that there. Racing, not racing. Racing. X. Okay. All right. I'll assume I went slowly enough on that one. We all good? If you want to raise your hand if I'm moving too fast, or send me something in chat, or have a question. Okay, let's go to the next one. Ooh, recycling. The Recycling Club collects cans and bottles for recycling. The ratio of cans to bottles collected was 8 to 9. If they collected 240 cans, how many items to be recycled did they collect in all? Okay, so here we're finally mixing it up a little bit. We are going to start with the ratio box. Ratio. Actual count are 3 rows, 2 columns, and then cans. Oh, yes? Is there a question, or am I going too fast?
I have a question.
Sure.
I don't understand this. Let's say the recycling club collects cans and bottles for recycling. And then I asked how many items to be recycled did they collect in all?
Because the question is the total. So that's what we're going to be looking for this time.
Oh, okay.
Ooh, spoilers though. I was hoping people would figure that out themselves. But yes. Whoops. Okay, and...
Can we just use mental math?
Total. No! We'll go through the steps. That's the whole point of this. I'm not doing this for my health. I'm doing it to walk through the steps. So just by practicing it, you can memorize how to do it and then apply it to different situations, because this is not going away. The next one, I believe, is going to be dealing with percentages and using these boxes to figure that out. Figure out what percentage. So settle in, get used to doing these. You can do them however you like when you're no longer told to do them this way. Okay, that should have given you plenty of time. So let's see. So there are 8 cans to every 9 bottles. So the total for that would be 17. And then we know that there are 240 cans. We do not know how many bottles, but apparently we don't care. And we've got our total. And that's what we want to know. We want to know the total. We don't care how many bottles, so we can eliminate that. And then bring these over. So we've got a ratio of 8 to 17 equals 240 times t. Okay, so this time, and so you might notice that that's there now. I mean, technically I could do it so my t was over on this side of the equal sign when we do our equation, but nah, why do that? So then we'll get 8 times t equals 24 times 17, which means 8t equals, let's see, so we're going to be doing multiple things there, 7. I think might have to erase this and bring it down. 20, 2 times 17, 16. Okay. Okay. Get us to here. And then divide each one of those by 8. And so let's see, looking at that, it looks very mentally mathable, doesn't it? Let's see, so 8 divided by 40 would be 5, and then a 0, and then 8 divided, no, there we go. 8 divided, okay, I'm just going to do that. Oh, okay. Oh, right. Okay. So 510 items were collected in all. So let's see. Well, I guess I'll say items. All right. Oops. Oh, Beer, did you? Sorry, I didn't see there. I was focusing on.
No, I just raised my hand. It's fine.
Oh, okay. What's up?
So can't you just do like 240 divided by 8 and then multiply that by 9 and then add 244?
Yeah.
Like I said, you can do whatever method you want when you're not asked to do it like this. But this is the Saxon method that's being taught in the Saxon book. And so if they are asking you to do it like this, they're asking for you to practice a method, not to just solve the problem. A method that can be applied to future, more complicated problems. So for now, for the purpose of this lesson, please do it this way. Okay, let's see, how are we doing on time? Okay, I'm going to do one more here, but I'm going to try to be a little bit faster. So you try to be a little bit faster. I'll give you a couple of deep breaths, quick ones. Okay. Ratio box. Ratio actual number. Actual count, excuse me. Which, you know, same thing. A ratio of big fish to the little fish in the pond was 4 to 11. If there were 1,320 fish in the pond, how many big fish were there? Okay, so big, little, total, big, 4, little, 11, total, 15, and actual count for total 1,320. This can be big, this can be little. Little is a little useless. Making the equation. Making our ratios. 4 to 15 equals b over 1,320. Cross multiplicative goodness being 15 times b equals 1,320 times 4. Okay, simplify that. 8, 12, 1. Then 15b equals 5,280. Divide each one by 15, and we are done with this for the day. Okay, and let's see. Maybe 45. And 78. Okay, so let's see, that would be 4 or 5. Okay, and then I guess a 2. So we can say 352 big fish. Okay, let's do the odds. And I'm gonna stop the video here.